Okay, we're still in graphing quadratic functions, the calculator section. You're allowed to use it. Number 8 says the instructions say write the function in intercept form. Intercept form looks like this: y equals ax minus, whoops, my mistake, ax minus p and x minus q. That's intercept form. So we want to get the x-intercepts. Okay, so we're going to have to look for some factors, or we can use the quadratic formula is really what we're going to have to do. So I'm going to try to factor this. The factors of 3 and 5 are 15. 15's factors are 1 and 15, 3 and 5. And it turns out I want them to add to -8. Well, if I add those, I get 8. So if I change them both to negative 3 and -5, I'll get -8. You can see that a little bit better there. So that's what I'm going to do. And some people aren't sure what to do there. So what you do is you write this out here. If you do by grouping, you get minus 3x minus, whoops, I did the wrong number there, 5x. Then I'm going to go back to 3x squared and plus 5. I need to add my own grouping in. And I'll go back here, and then I'm going to, whoops, I totally botched that up with the grouping. Okay, 5 is there written properly. Grouping, got to capture the negative. I've got another one right here. So now I'm going to say what comes out of here. I'm going to take 3x in the first parenthesis, and I got x minus 1. I'm going to take a negative and a 5 out of both, and I get x minus 1. Turns out I got this and this. So I get x minus 1, 3x minus 5. So it's almost looking like this, except you notice that each of these has a 1 in front. So I need to divide this by 3 to get this to cancel out and become a 1. But I can't just divide by 3, so to offset it, I'm going to come outside and multiply by 3. This way, this 3 is canceled out by this 3 in terms, but I'm using this division of 3 to affect this parenthesis right here, and I'll keep that up front there. So this becomes 3x minus 1. Actually, this is g of x, by the way. Okay, and then inside I've got here x minus 5/3. So I've now written it in intercept form. Now I need to give you, it says give me the x-intercepts, the zeros of the functions. Well, set this equal to 0, set this one equal to 0, and we get x equals 1 or 5/3. Okay, that was number 8. Number 9, I'll do in a second here. So number 9, the instructions say write the function in vertex form, then identify the vertex. Well, vertex form should look like this. F of x equals ax minus h squared plus k, which means we really need to complete the square. Okay, that's what we need to do. Now, here's where lots of people get messed up. You are only factoring out of here, and we're going to slide this over here and get it out of the way. Okay, we're going to factor out of there because we want this to be a 1. So I'm going to have to divide everything here by 2 in the red parentheses. The 99 is not affected. So when I go and do this, I'm going to get f of x. I'm going to get factor out the 2. It doesn't disappear, it stays there. I'm going to x squared minus 14x. Then I'm going to add something, put a blank there. And because I added something right here, I have to subtract something outside. It's the same amount as inside. So these have to be the same amount. And then of course I've got my plus 99 sitting outside there way out here. Just brought over to stay out of the way till the very end. So now how do I know what I put here? I divide that by 2. and then I square it. So it's going to be negative 7 divided by 2. Negative 7, sorry, negative 14 divided by 2, which is negative 7 all squared. And so we get that there. Now here's the mistake most people made. They put 49 out here because negative 7 times negative 7 is 49. But they have a major problem here because it's not, you don't have two negative 7, you don't have one negative 7 squared, you have two of them. So I need to fill this in with two of those. So when I factor this now, or when I go to factor this, I got a 2. This is a perfect binomial squared, so it's going to be x minus 7 all squared. This right here is 98 negative plus 99, so that's positive 1. Now it's in vertex form. It looks like this down here. It looks like that, so good. We've got 2 points there. And then they also said give the vertex. The vertex, the x's lie, so this is a 7 plus, 7 and 1. And there's your other point. And there's one more I'm going to do. So number 10, it says the graph of y equals 2x squared minus 12x plus 23 is shifted 6 units to the right and 3 units down. What is the equation of the new graph in vertex form? Well, it's hard to see 6 to the right and 3 units down in standard form, so we need it in vertex form, and we did that on the previous problem, and we wanted it to look like this. Y equals ax minus h squared plus k. This is an a here. Okay, so we want to make it look like that, so we need to complete the square. So what I'm going to do again is I'm going to write, and so that will get at this, we want to get this into the vertex form. So I'm going to write y equals, I'm going to group this so I can factor a 2 out, and I'm going to take this, just slide it over, and I'll deal with it later. So I'm going to factor out the 2, so I get 2 here. Get x squared minus 6x plus something minus the same amount, and then I've got the 23 sitting outside here. So again, so what is half of 6 divided by 2 and then square it? So that will be negative 3 all squared. So most people want to put negative 3 all squared and they want to be done, but again, I'm going to emphasize that there's 2 negative 3's all squared, so we have to put a 2 in front here to balance it out, to keep it all balanced. So that's what I'm going to do, and then we're going to get y equals 2 x minus 3 all squared, and then this turns out to be 2 times 9, which is 18. So we got negative 18 plus 23, and that looks like positive 5. So we have positive 5 here. So we've got it there. We get to here, and we've got most of the hard work done, but that's not what the problem asked. It says shifted 6 units right, 3 units down. Well, down units work really nicely. Down is minus 3. So we're going to subtract 3 from the 5. Now, remember, your x's lie to you. In here, your x's lie. So we would normally want to say plus 6, but it's going to go inside. So we're going to say minus 6 here to that 3. And so you get y equals 2 x minus 9 all squared, and we've got plus 2 here. Okay, and if you think about it, we can check it really quickly here. The original vertex up here around here was x's lie to you, so that's a 3, and this is a 5. And if you were to read the next vertex, you get x's lie 9, and this is 5. And if we go back through the stuff, I'm just going to change the pen here. We said that you would normally think you add 6 and that you would subtract 3. Actually, this is supposed to be a 2 here. I totally wrote it wrong. Okay, so I'll rewrite that. This is supposed to be a 2. Okay, and it seems to work. So you can check by the vertex that what we did was right. By subtracting 6 was the same thing as if you did it the other way, adding 6 once you knew the vertex. Okay, that's it for that one.